So we're going to talk about precipitation, an extension of the discussion of solubility. So we can understand precipitation reactions better by looking at the reaction quotient. So the reaction quotient is calculated the same way as the equilibrium constant, but instead of using equilibrium concentrations, it uses whatever concentrations are currently present. So KSP is the value of the product at equilibrium. Q is the value of the product under any conditions, product of the product concentrations. So comparing Q to K will tell us what's going to happen in the reaction. So if Q is equal to KSP, that means the solution is saturated. You have the maximum amount of ions that can be dissolved in that solution. So if you add more solid, it's not going to dissolve, it's just going to sit there. If Q is less than K, that means these concentrations are smaller than the equilibrium concentrations. And so the solution is unsaturated, and you can add more solid and expect that at least some of it will dissolve. If Q is greater than KSP, the solution is supersaturated, and the solid will precipitate out of solution, usually. There are some weird things that happen with supersaturation. So any questions about that? So we can look at Q and predict whether a precipitation reaction will occur when two solutions are mixed. So the first thing we need to do is identify the possible precipitate, and then we'll calculate Q. If Q is greater than KSP for that compound, we can expect precipitation to occur. So in Chem 1A, when you mixed solutions, if we didn't care about concentrations, if it was on the generally insoluble list, then it was a precipitation reaction. But if you have very small quantities, you can mix those compounds together and not get a precipitate because you haven't reached the equilibrium concentrations yet. So let's look at this one. A solution containing lead 2 nitrate is mixed with one containing sodium bromide to form a solution that's 0.06 molar in lead nitrate and 0.015 molar in sodium bromide. Does a precipitate form in the newly mixed solution? Well, it's always a good idea to look at the chemical equation. So we've got lead nitrate, and we've got sodium bromide. And that's going to do one of those double replacement reactions. So we're going to end up with, well, let's write it out in case you've forgotten. So we have lead 2 ions and nitrate ions in that one, sodium ions and bromide ions in this one. And what they're going to do is they're going to swap partners. Sodium and nitrate, potassium and bromide. And so you can write them over here. We'll get sodium nitrate plus lead bromide. Which of these is our possible precipitate? The PBr2. So that will form a solid if there's enough to saturate the solution. Sodium compounds are always soluble, no exceptions, so that's going to be aqueous. So just going back to Chem 1A, Swapping partners, the double replacement reaction is how we predict what the possible products are. Now, is this balanced? No. There's 2 bromides here and only 1 there. If I stick a 2 here, then that takes care of that. And then I need a 2 over here, and everybody will be happy. So we're looking at PBr2. And all compounds dissolve at least a teeny tiny bit. We need to look at the solubility equation for this so that we can write the correct KSP expression. Right, so when this dissolves, I get 1 lead ion and 2 bromide ions. And so then KSP equals concentration of the lead ion times what? Concentration of the bromide squared, yep, because of this 2. So that's at equilibrium. We're not actually calculating KSP. We were given KSP. So what we're actually interested in is Q, which is the same calculation, but it's current conditions, not at equilibrium. So Q will equal, here's our concentration of lead, and bromide squared. I knew I forgot something. So 0.06 times 0.0158 squared